Hi class. So I gave you a printout of a couple of application problems related to quadratic equations. And I hope you were able to work on that first, because that's where you're going to learn the most, is by struggling with this. And then you can use this video as a check. If you have not done these equations, then I encourage you to stop the video and go back and try the problems. Really think through them, struggle with them a little bit, and struggle with them a lot. That's how you're going to learn the most. So if you haven't done this, go ahead and stop now and go back and do the problems. All right, welcome back. Hopefully you were able to do those. That's going to really help you. But let's tackle this problem. We've got a company, and their revenue, that's just a fancy name for income. Their revenue is from selling X computers, given by this formula. So revenue, income mean the same thing. And then they have a cost. Their cost to sell the X computers is given by this formula here. This is the cost equation. Now, the first problem says write a profit function. Profit, well, you might remember that profit equals income minus cost. So we could actually write a function here for profit. It would be income, well, we're calling that the revenue function, minus the cost function. And so that's going to equal 680x minus, now I'm going to change the color for the emphasis here. I'm going to minus something. I'm going to minus the cost function. Okay, the cost function was 10,000 plus 2x squared. Now, what I've written there is an error. This is incorrect. And it has to do with this minus, because I am minusing the cost. Now, the cost is this whole group. You need parentheses to do this cost subtraction correctly. And so that is going to distribute and actually affect the sign of two things here. So we got to be careful when we write this. We're going to have 680x. We're going to have 10,000, 2x squared. But I'm going to tighten that up a little bit. But when we distribute, this distribution comes in here, it's going to make the 10,000 negative. And when the distribution comes in here, it's going to make the 2x squared negative. So in the end, when we simplify this and put it in order, we'll have the profit function. It's negative 2x squared plus 680x minus 10,000. So those negatives are really important to take care of and watch them carefully. Okay, the vertical intercept point. You might remember that the vertical intercept point comes from the number c. And we have c there. So our vertical intercept is 0 minus 10,000. And then they say, okay, let's interpret the meaning of this point. And the meaning of that point is, this is not a very good sentence, but they've sold 0 computers, which implies they are 10,000 in debt. Probably a sentence would be better to say when they started. I just finished off the sentence there, but you can see that a sentence, there's many ways to express this, but when they started, the company was $10,000 in debt. All right, so that's taking care of a few of the questions in this problem. Let's scroll down here and continue with the rest of it. It says, draw a good graph of the profit function, including labeling the window, the size. Use any method to find the maximum point. Probably the graphing calculator is the fastest. Second, how many computers must be made to make the maximum profit? And how much is the maximum profit? Now, as you may remember from the equation, A equals -2, and it's a quadratic because it's x squared, so that means the parabola has to be shaped down. So the vertex here is the maximum point in this problem. So everything here is about the vertex. And like the problem said, there's many ways we could find this vertex point. You can plug this in the calculator, which is a good strategy, or you could do it algebraically. Now, I'm going to practice the algebra model, even though the math might be a little bit hard because we have some large numbers here, but let's find the vertex. So the vertex has a coordinate for the x coordinate, and it follows the formula -b/2a, which will equal, in our situation, -680 divided by 2 times -2. So I did the math for that really quickly, and I got 170. I just plugged it into the calculator. Now, the y-coordinate of the vertex comes by plugging in the 170 into the calculator. And so that also is going to be some calculator work here. But I'm going to put the square there, plus 680. Oops, that's minus 10,000. And so what we're going to do is we're going to take the x value that we found and plug it in. And the rest is just, that is a big calculator problem. It's going to be a large number. So let's just plug that into the calculator and see what we get. All right, so one little adjustment back here. I'm plugging it into the equation, which is not an f, but it's a profit function. And maybe because it's a profit function, I should make it green, because this is profit. And it turns out, after I put it in the calculator, it's a pretty large number. So the profit of 170 computers turns out to be $47,000, $47,800. So the vertex point is 170,478,0. That's the vertex point. Okay, now they're asking us to sketch a graph, and at this point the main thing we need to answer these two questions is right here. Everything we need is right there. So the rest of the graph isn't super critical in this situation. And so I kind of am deferring back to this, that graphing the calculator may be fastest to graph it in the graphing calculator. But I did want to review with you the algebraic approach to finding the vertex. Okay, so let's graph this thing. Now we do have a few clues, but first we're going to have to get the equation typed in there, of course. Alright, so you can see that I put the equation in there. Notice I have the -2x squared and the -10,000. So I didn't want to make sure we lost those negatives that we had in there earlier. Now the window, to see the graph, We have several clues, though, that are going to help with this window. First of all, X means computers. How many computers that we're working with? Now, this window before it was negative 20, but that doesn't make sense. We can't make negative computers. But also, we found the vertex. The vertex was 170, so the x's have to go to 170. In fact, 170 is the vertex point, which is kind of like halfway. So I'm thinking at least double. So that'd be 340. If the vertex is halfway, a double 170 is 340. I'm going to round it up to 350. So I'm going from 0 to 350 computers. And let's do the scaling. Since we're going all the way to 350, let's count by 50s. 50 computers for each tick mark. Now, the Y numbers. The Y numbers are the profits. Now, remember over here, we started in debt at negative 10,000. So, let's start there. I'm not exactly sure where to start the Y's, but that's probably a good number to start with, and we'll see how it takes shape. Next, we have the maximum profit. The maximum profit was $47,800. So why don't we round that up to 50,000? Now that means I've gone a distance of 60,000. Let's count by 10,000s and see how this graph looks. Alright, so that worked out pretty well. Now, since we have the maximum up here at the top and we have it in the calculator, it might be a good idea to check our algebra, because down here we have the algebra showing that it was 170 and 47,800. So let's let the calculator first of all check that. Make sure our algebra is good. So I'm going to use the second trace button. And I'm going to look at number 4, which is the maximum. Hit enter. And in order to do this, I have to move to the left and set a boundary. Move left, hit enter. Move right, set a right boundary. Going past the max, hit enter again. And then I need to guess. So third time, hit enter. And I'm noticing at the bottom 170 with a tiny round off error in the calculator. So 170 and 47,800. So that is confirmation. My solution is good. Okay, so and we can use that as a quick sketch here. So for the window, let's see, we put our axis right here. And we went from 0 to 350, and we went up to 50,000, and we started at negative 10,000, and the graph, we just need a rough sketch. It went something like that, and here's labeling our vertex. Okay, now I'm out of room. Let's see how that does for me over here. They ask us 2 questions. How many computers must be made to make a maximum profit? They have to make 170 computers to get max profit. So they've got to make this many computers to get up to that highest dollar. These are the dollar amounts here. And that's the first question. And the other question is, what is the max profit? The max profit equals $47,800. So there we have it. That's an application that looks at quadratic functions. You've seen other ones like the human cannonball, and the human cannonball was more interested in when does the human cannonball hit the ground. That's a different question where we have to find zeros. So in this problem, that would be, when does the company reach zero profit? Well, that would be a bad thing in this company. But sometimes we are interested in zeros, and sometimes we're interested in the max or the min. And in this problem, it was about the max. So go back and study other examples, and like the human cannonball problem we studied, that was more about the minimum. Okay, let's move on here and look at one more application. Peter's Palm Pirates, a manufacturer of electronic organizers, estimates that when X 100 Palm Pirates are made, the average cost per unit is given by that equation, where C is hundreds of dollars. What is the minimum cost per unit, and how many units should be made to achieve that minimum? Okay, so this is really a repeat of the previous problem. It's asking for costs, and we want costs to be a minimum. Now, one thing we should notice, though, is the cost equation. I'm going to change colors because cost is related to going into debt. That would be like being in the red. The parabola A equals positive 0.25. which means the parabola is going up, which means the vertex is at the bottom. So the smallest cost is at the vertex. Alright, so this becomes about the vertex again. I need to find the vertex point. And so let's do some calculations here. Now we've got the formula, same as before. Negative b over 2a, which will be negative of negative 1.8 over 2 times 0.25. I'm going to plug that into the calculator. Okay, that comes out to 3.6. Now, the y part of the vertex, that's going to come from plugging into the cost, the 3.6 number. So we have our cost function, and we're going to plug in the 3.6. And then we're going to have to rely a lot on the calculator to do this calculation here. So in this particular problem, I'm not worried about the graph. I'm not worrying about other details. All I want is this one point, the vertex point. And so if I plug this in, I'm just going to run it in the calculator as one calculation and hit enter and see what we come up with. So we get 1.38. So there's our vertex. Let's change the color though. I didn't mean for that to be red actually. So the vertex is 3.6, 1.38. Now, what is the minimum cost? And how many units are we supposed to make? So x equals the number and y equals the cost. And in this case, the number is 3.6. But remember, this x is in hundreds of dollars. So what that means is 3.6 times 100. which is 360 of these Palm Pirates. I'm thinking they're making a play on a long time ago there used to be these organizers. They were like the predecessor to cell phones. They were called Palm Pilots. But anyways, they're making 360 of these, and when they do, their costs will come out the lowest they're going to be. They come out as 1.8. And remember, those are also in hundreds of dollars. So we have to times that one by 100 as well. So that's going to be $180. Okay, just forgot to clarify a little bit here, but it's $180 per unit. That's part of the definition of the cost. The cost is in dollars, and this is cost per unit. Little detail, but we got all the solution here. And so that is an application problem we solved based on knowing the vertex. Okay, now hopefully you did these two. If you're still here, I'm really proud of you for doing this extra study. I have a bonus problem for you. You didn't do this one, but here's a bonus. More work. No, but I hope this helps you learn more about applications of quadratics. It says the formula for throwing a baseball into the air is represented by h equals negative 16t. That should be to the second power. That's just kind of a computer font error. Negative 16t squared plus 12t plus 40. Okay. So we have a baseball function, and we also notice that a equals negative 16, and it's quadratic, so the parabola has to be going down. And that's exactly what we would expect with a baseball. And we also know, too, that it's starting at 40. Maybe they're on top of a building or whatever, and they're throwing the baseball, and it's going up and then coming down eventually. So this will be height, and this will be time. And we're doing time in seconds here. And our question is, when will the ball hit the ground? How many seconds will it take? Well, hitting the ground means h equals 0. So we have to solve 0 equals negative 16t squared plus 12t plus 40. Okay, because it's a quadratic equation, it equals 0. We have to start equal to 0. We might be able to factor, and we can definitely do the quadratic formula. But these numbers look kind of nice. I'm hoping that it's factorable. And the first thing that I can see to factor is a GCF. So that'll be minus 3t, and 40 divided out negative 4 is negative 10. And I'm going to hope to keep factoring. Now you're going to have to do some trial and error in here, but I'm not going to take time to do all that, but it turns out it is factorable. 4t plus 5 and t minus 2. And then minus 2 minus 5 gives us negative 10. And 4 times 2 is 8. Negative 8, and then the 5t is 5 minus 8 gives us the negative 3. It turns out it's factorable. And then when we solve, the 4 is a constant. No, it's not a player in this, but the t and the t are going to give us solutions. So we have to solve 0 equals 4t plus 5, or 0 equals t minus 2. And so with a little bit of algebra here, I'm going to add 2 minus 5 going to skip a step here and just say t equals -5 fourths. I got two solutions. Okay, now what do those solutions mean? They mean time. So time, negative time is back here, and negative time doesn't make sense. This is not part of when the ball was really in the air. The ball didn't start in the air until after 0 seconds. So negative time doesn't make sense. This solution is an extraneous solution. But I do have one good solution over here, that in 2 seconds, it's back on the ground again. Because when t equals 2, h equals 0. That's what we have solved. So, in 2 seconds, the ball hits the ground. So this is another quadratic application, but this time we were focused on the 0, not the max or the min, or not the vertex. Hey, study really hard with this. There's some other applications that you'll come across with. I really want to encourage you to reflect on them and think about them. Study hard, and I'll see you in class.